November last year, I made a video about the introduction to AWS V2 library for Java. And at that time I said that the next video I will show how to set it up with Spring. In the end, it didn't happen. I had some couple of other ideas for the videos, and later on I didn't have time at all to make any videos. But yesterday I finally had time to record something and actually to try things out. So today I would like to show you how to set it up, the relatively new library from AWS with Spring. And you may think that this should be quite obvious, and actually for setting up like a hello world type of thing, it's definitely not really hard. But if you want to make it right, if you want to be able to test your classes locally, I mean integration testing without using the real AWS environment, there are a couple of tricks that you can do that will make in the end your code easier. And this is what this video is going to be about. So if you want to follow the steps, you don't really need to have an AWS account, because you can always spin up the, let's say, like the local clone of AWS, which is called Localstack. But of course, if you want to try it really with the real environment, then you need to have an AWS account, and you have to have your local environment configured to use AWS, meaning this credentials file with AWS secret and AWS key. So let's jump now to the code. Maybe before we get to the code, let's take a look at AWS SDK for Java website. So there are two places where you can look for information. One is the official website, and it's over here. And here you can find a link to developer guide for V2 version. And another one is just a repo on GitHub. Both of these websites don't provide the same quality documentation that you might be familiar with if you use, for example, Spring Boot or Spring Framework. Nevertheless, it gives some hints how to start. SDK is distributed in a Maven repository, and there are two ways how we can import it. The first way that they mention here is that we can just take the whole library AWS SDK for Java as a dependency, and it brings all the services. But then when it says all the services, it means that it's gonna be every SDK for every service. It's like, not sure if there are tens of them or hundreds, but it's like means like lots and lots of jars that you definitely don't need. So the better way is to add the dependency management section to the POM XML. This takes from us the burden of specifying the version for each dependency, and we need to keep most likely all the dependencies to all the services that we are going to use with the same version. Here we just specify the version once, and then we can just add them without putting the version. So probably the example is over here. If we want to use SDK for EC2, we just put these 4 lines in a very similar fashion as we added the dependencies to Spring Boot starters. So let's take this dependency management section and put to the POM XML. I have here just empty Spring Boot project, just the very basic starter, nothing special, except I added Lombok. You will see later why. So if we add this dependency management section, now if we decide to use one of the services, it's enough to add it here. And actually, we will make an example with Dynamodb. So now if I add the Dynamodb, it should be already in my class path. The way SDK is structured is that each AWS service has a corresponding client and client async for doing non-blocking calls. So in our case, we are going to use Dynamodb client, so the blocking one, and the easiest way to create it is just to use dynamodb client.create. It will use, depending, if you run in the AWS environment, it will just use the same region as the instance is in and the credentials that are available for the machine. And also, if you run it locally, it means that you have to have your local machine configured to use AWS. So to make it work well with Spring, we have to, of course, turn it into the bean. So I will remove just this line over here and create a new bean that will return a Dynamodb client. We can use this Dynamodb client in any class we want. Like the easiest way just to try it out is to create an application runner that will use this Dynamodb client, and we can, for example, list all the tables that are in my AWS account in my region specified in my configuration. So I can just list all the tables and just print the table names. Okay, so now let's see if it works. When I go to my AWS console, I can see that I configured here two tables. One is my table and the second one is person. So this is exactly what we should see here in the command line output. But what if we don't want to always run against the real AWS environment? And while it may make sense during development, it definitely doesn't make sense when you run your integration tests, or if your integration tests run on the CI server. So fortunately, there is a tool called Localstack, and Localstack is kind of like a AWS clone that you can run locally. It's in the end, it's a collection of many different Docker images that imitate the AWS services, implement their APIs. And I must say that it works really, really well. It does not cover all the AWS services, just to make it clear. So it says that it covers core AWS services in the base edition, and there is also a pro edition that is coming soon that will maybe cover them all. I'm not exactly sure yet. So if we go to its GitHub repository, you will find here a Docker Compose YAML file, and we can use this Docker Compose to very easily spin up the local stack locally. Of course, you have to have Docker running on your machine. So I will now copy this file and paste it into my project. And this YAML file is structured in a way that we can pass a variable services where we define which services do we want to spin up with local stack. So basically, we don't want to spin up them all, usually at least. I will go to my terminal, and in terminal type docker compose up, but before this it will be services equals to dynamodb. And this is what happens on my Mac. Not necessarily it will happen on yours, but there is a trick to make this error go away, and I will have it somewhere in my history. So it's just changing the temp directory. So if I will spin it up like this, it will start under the hood the Docker container with like imitating DynamoDB. And this will be running on port 4569. So if I go now open another terminal window, I can make sure that it is working. So I write telnet localhost, and what port was it? It was 4569. And I am connected. And now we need to change the configuration for the DynamoDB client to use localhost 4569 instead of real DynamoDB. And the way to do it is, instead of calling create, we can call a builder. And in builder, we can pass an endpoint override where we can pass the URI with HTTP localhost 4569. And then we just call build, and this is how we have the DynamoDB client hitting our localhost. So now if I run it again, the result should be that there are no tables defined, because there are just no tables defined. But obviously we cannot leave it like this, because now it's hard-coded to use the localhost. So the natural way is to to externalize this URL to a properties file. So let's create a new class. This will be called Dynamo properties, and this is going to be a configuration properties class with a prefix dynamo, where we can set the URI, and we will just call it endpoint URI. And let's turn it into the data class so that Spring can set these properties. And now in application properties, we can just say dynamo endpoint URI, http localhost 4569. So here, instead of hard coding, we just take the Dynamo properties and get endpoint URI. And now the last thing is to enable these configuration properties. The previous video that I made is like all about configuration properties. So if you got confused at any of the stage, I would recommend to have a look at this one. And now we could split application properties into different profiles. So for example, that for profile local, we set this endpoint URI to localhost, and for profile production, yeah, so we set it to what? Well, actually the client knows much better what's the real endpoint URI depending on which region it uses. So it would be silly to set it up manually. So instead of doing it like this, it's actually better to say that if this endpoint is not null, then we set this endpoint override. And this is where this builder pattern falls apart, because what we have to do is we have to refactor it to Dynamodb client builder. And then if Dynamo properties get endpoint URIs not equal null, then we just do builder endpoint override. And then we return builder build. And this means that if I have this property, it will connect to localhost. If I remove it, it will connect to the real Dynamo. And this is the flexibility that I believe we want to have. But it works well only if we have a single client. Let's say that we want to now add another dependency to S3. And let's create an S3 client. So it will follow pretty much the similar pattern. So this will be S3 client that takes the properties. It will have to be S3 builder. And that's it. So it has to be called S3 client. So in every client that we are going to use, we have to copy paste the same code. And in this example, I just override the endpoint, but this builder has much more methods that we potentially may want to override. So for example, we can specify our custom HTTP client where we configure what is the size of the connection pool with different timeouts. We can also set the region manually and so on. So we would like to avoid copy pasting this whole piece of code for every client we define. So we have to move this piece of code somewhere else, and it can either be a separate class, it can be a private method, depends how do you structure your configuration classes. I will just move it to the private method, but the signature of this method is really, really tricky. So I will paste it from my clipboard where I copied it before. So like you don't have to dig too much into the details, but it will basically let us apply Dynamo properties on AWS client builder. So in this case, we can take this piece of method over here and return a builder. And with this method in place, we can refactor this code in a way that we apply Dynamo properties to a client builder, and then we just build it. So instead of having multiple lines, we have just one single line, and in the very similar way, we approach the Dynamodb client. So you have to say that it looks much better. The thing is only that this AWS client builder lets us set up endpoint override. It let us set up region, but for example, it doesn't let us set up the HTTP client. So in the end, depending on what do you want to configure, you will most likely have to have multiple methods like this or come up with a smarter way to do it. Okay, we are at the point where SDK is set up, but now I would like to show you how to do something useful. And this SDK is super, super low level. So actually there is so much code needed to write to do anything really simple. that I will just write the first part with you, and then later on I will speed it up. So at the beginning we will create a new table. So there is a create table request, and for every request you make to AWS, there is this pattern. There is a like put item requests and so on, and they all follow this weird. I mean, the pattern is maybe not weird, but in this case it's a little bit abused. So every time you want to create a new object, you use the builder pattern. And the create table request, I will move it to the next line because this gets actually quite long. We need to specify the table name, and let's call this table book. And then we have to provide the key schema, which will mean what is our primary key. And again, it's a builder, so the key type will be hash, and attribute name, it's ID. And now we need to repeat the same attribute without as ID in attribute definitions with specifying its type. So again, now we have to put the attribute name again as ID, and the type we choose to be string. This is the convention used in Dynamodb. So now after we build it, let's execute Dynamodb client, create table, and create table request. So let's list these tables before we make a request and after, and when we run it, we should see that the table is created. Nope. No provisioned throughput. So okay, so it's not enough. When we create a table, we also have to specify what is the provisioned throughput, and again, it's a builder where we specify what is the write capacity and how many read capacity. 5, as far as I remember, is default. It would be nice if actually SDK embraces the default values. So let's run it again. And now the table is there. And now I would like to show you how you can write tests that runs against the local stack environment, not against the real AWS. So we will do it using test containers. So the first thing that we will do maybe is to move content of this application runner into a separate class. So instead of having this application runner, I will create some service that will just create tables. I know that it doesn't make much sense, but it's just for the demo purposes. So we will just make it return void, create table, and we will put the table name, and this will just basically encapsulate all this crazy logic. So of course this uses Dynamodb client. And let's mark it as a service. Now let's add dependencies to test containers, and we need actually 3 dependencies. The one is just a test containers core. Another one is test containers integration with Localstack, and this one under the hood uses AWS SDK v1. So we also need to attach the dependency to the core of AWS Java SDK from version v1. And you may be wondering if it doesn't conflict with v2. The good thing is that AWS made the v2 library completely independent from v1. So there's no package conflict, no naming conflict, nothing like that. You can always have v1 and v2 at the same time on your class path. So let's just add this test container version property. And the latest one is 1.11.1. So now I can go back to my some service class and create a test for it. Setting up test containers with Spring requires some ceremony, so I would prefer to move this whole ceremony to base integration test class that I will now create in my test directory. And this will be an abstract class in which we will create a static variable of type local stack container. And this will be a new local stack container with services, and here we can specify that we want service, not SQS, but Dynamodb. And then in the static section, we start the container. And now we have to have a way to pass the IP address and the port of the created container to Spring Boot application. So we can create another static class that I can call initializer, and this implements application, configurable context initializer. This is not easy. There is something with context initializer, and it will be application context initializer when we pass configurable application context. And this has just one single method where we can create test property values. So this will be test property values of, where we can just pass pairs, like in our case it will be Dynamo endpoint URI. And the value of it will be, we can take from the local stack container. It gives the get endpoint configuration method where we have to specify that it's for the service Dynamodb. I will move it again to the next line so that it's a little bit better visible, and then get service endpoint. And now these values can be applied to configurable application context. So once it's there, we can use this initializer in the following way. We can put context configuration annotation on this class, and then put initializers where we say that we are going to use initializer class. And now if there's a compilation error somewhere here. And now if we go back to some service test, we just make it as run with Spring Boot, Spring Runner class, and then Spring Boot test. And now if we just put any method, it should create the Dynamodb with test containers just before the Spring context starts. So here in the logs, we can see that the test containers are spinning up SQS. Sorry, not SQS, Dynamodb. And now once it's up, it will start Spring application context. So now we can write a very, very simple test that will have a some service, auto-wired, and also the Dynamo client that will verify that after we create a table foo, the table foo will actually be there. So is there a get table? No, so we have to do list tables, table names, and we can use assert j that it contains, and I have to remove this import first. So that it contains foo. And this, of course, all runs against local stack. It doesn't hit AWS at all. And the test failed. And the test failed because we don't use this name parameter anywhere here. So instead of hardcoding book, we will just pass the name, and let's run it again. Okay, so now the test has passed. This video got way longer than I expected. I actually had a plan to show also how to use it with Spring MVC or Spring Webflux which makes sense, but maybe let's do it in the different video. if you survived till this very moment, congrats. If you like this video, if you learned something, I hope I managed to explain all the steps quite well. If you're looking for more videos like this, check my previous video. There are pretty good, I believe, explanation on how to build a reactive application with Spring, Data, Redis, and Webflux. And also subscribe to the channel. When I have time, I will post more videos with most likely with a focus on Spring and AWS. So thank you for watching and hope to see you next time.